Not long after the first flight at Kitty Hawk, the Wright brothers, and many other inventors for that matter, began trying to find ways to make aircraft better. In a relatively short amount of time, aircraft designs went from canvas and wood structures with very weak engines to metal structures with very powerful engines. With each new innovation, propeller-driven aircraft became stronger, safer, and much more efficient. The next great revolution in aircraft design came with the development of the jet engine. This type of engine truly changed air travel dramatically. It enabled aircraft to fly farther and faster than propeller-driven aircraft, while improving safety and efficiency. However, since the beginning of the jet age, technology innovations in aircraft have been more incremental than revolutionary. Small steps forward have continued to make flying safer, but what will be the next great revolution in air travel? To help answer this question, NASA researchers are working on new designs that could change air travel once again. New aircraft shapes, cleaner burning fuels, and new materials could be the first steps in the next revolution in aircraft design. I spoke with Bob McKinley in the Vehicle Systems Program Office at NASA Langley to find out what future aircraft might look like.
The Vehicle Systems Program Office is focused upon working on improving the aircraft of the future. In particular, we want to work on quality of life for the citizens of this country, and that's where our investment is aimed, and also to make aircraft safer and cleaner and better for the environment. Some of the aircraft that we're working on would be subsonic transports like jetliners that would fly quieter, land and take off quieter, and supersonic aircraft that could fly over land without making a sonic boom, and personal air vehicles that you and I could use in place of an automobile.
Now, will the aircraft of the future look similar to the aircraft we see today?
Some aircraft will look the same as what we see today or very similar, and some will not. One of the concepts that we've been working on in terms of advanced technologies is the blended wing body, or the BWB. And that aircraft is aimed specifically at being much cleaner in terms of emissions and fuel burn.
Current aircraft are much more efficient and quieter than aircraft designed, say, even 30 years ago. But public demand for quieter and more environmentally friendly aircraft continues to grow. In an effort to meet this goal, NASA is researching an aircraft called the BWB, or blended wing body. The BWB is a hybrid shape that mainly resembles a flying wing, but also incorporates some features of a conventional transport aircraft. The futuristic airframe is a unique design with efficient high-lift wings and a wide airfoil-shaped body, allowing the entire aircraft to generate lift and minimize drag, thereby increasing fuel economy.
In addition to the blended wing body, we are working on aircraft that would cruise at a higher speed. Today's planes fly at between 500 and 600 miles an hour. We call it Mach 0.85 is about the standard. And what we'd like to do is move to an aircraft that allows us to fly at Mach 1.6 to 1.8, which is over twice as fast, say 1,200 miles an hour. And you'd be able to get from New York to LA in about 2 hours. Now, the technology exists to do that today. We have supersonic aircraft. We could make aircraft that would efficiently cruise at that speed, and the Concorde is an example. Aircraft like that can't fly supersonically over the United States or over any landmass because they create a huge sonic boom as they do so.
A sonic boom is a noise similar to thunder, caused by an object moving faster than sound, about 750 miles per hour at sea level. As an aircraft travels through the atmosphere, it continuously produces air pressure waves, similar to the water waves caused by a ship's bow. When the aircraft exceeds the speed of sound, these pressure waves combine and form shock waves. These shock waves are heard as a sonic boom when they hit the ground. This boom is so disturbing that aircraft today generally only break the sound barrier over water or in restricted military space. But new testing at NASA might soon change that. In recent tests, NASA researchers successfully demonstrated a way to lessen the impact of a sonic boom.
Flight cleared, high altitude supersonic, entry exit point 1, advise and complete the corridor.
They found that by designing the wings and body of an aircraft to a specific shape, the pressure waves generated can be kept from merging together. The resulting shock waves are therefore much weaker in strength, and the sound heard on the ground is less intense. With this new breakthrough, supersonic flight over land may finally be within reach. Another program that NASA researchers are currently working on may completely revolutionize the way we currently commute and travel in our daily lives. One of the major breakthroughs for personal travel in the 20th century was the development of the automobile. Before the automobile came along, the average person would only travel 5 miles a day or less. This number increased to 50 miles a day with the development of the automobile. The goal of the personal air vehicle is to enable the average person to travel about 250 miles a day by using their own or a shared personal air vehicle. The hope of NASA researchers is that personal air vehicles will be used in the 21st century, the same way automobiles have been used in the 20th century. This change would allow much more mobility and freedom in our everyday lives.
These aircraft may be able to completely displace the automobile, just as automobiles did horses. And we're looking at those in 3 phases. The first being what we call a quiet, conventional personal air vehicle, be very similar to what you see out on general aviation runways today. We hope to make these aircraft so easy to use that almost anyone would be able to take a few hours of training and get in and use this vehicle to get anywhere they want to go. The second phase would be what we call a vertical or short takeoff and landing air taxi. And this would be an aircraft that could take off in very short distances and hold 6 or 8 people, and you'd be able to just walk up like you do a taxi at a taxi stand and say, I need to go from Washington to Cleveland, and you'd be in and go. The third phase, we'd get into what we call a dual mode. And this would be, if you think Jetsons, this is the flying car. You'd be able to park this thing in your garage, drive out on your street, roll down the street a little ways to some short takeoff field, and fly. And maybe it's as simple as take me to Grandma's house, and it knows how to get you there. You know, we've come a long way since the Wright brothers took their short flight at Kitty Hawk. There have been a lot of innovations in aircraft technology in just a short amount of time that we've been in the air. And NASA's been a big part of that. And we're going to continue to be a part of that in the future.